Hello everyone, now we are going to solve the next question. This is a question of GATE 2012. This is a question of vibration. In the question it is written as a concentrated mass M is attached at the center of rod of length 12 as shown in figure. You can see this is a rod having length 12 and it is having a concentrated mass, okay, M. The rod is kept horizontally in equilibrium position by spring stiffness K for a very small amplitude of vibration, neglecting the weight of the rod spring. Undamped natural frequency of the system is, that means we have to calculate omega n. Omega n we have to calculate. So we need to apply the torque method. So you can see for a small angular displacement, for example, this is a small angular displacement of the rod we have given theta. So this would be the displacement of the spring, okay, that would be equal to 2L into theta, okay. So if the theta is in the direction I theta double dot, because we are considering torque, initial torque would be in the directions and spring force would be in the directions, and spring force would be K into 2L into theta, but we are writing the equation of torque, so torque would be about hinged point, so this is 2L. Okay, now in the horizontal conditions, I already told you that in the horizontal conditions you cannot consider mg torque because mg is already balanced by the initial deflection of the spring, okay. So we don't consider mg torque in case of horizontal condition, okay. So the equations would become I theta double dot plus K into 2L into 2L is 4L square, so that means 4KL square theta is equal to 0. Now we will calculate the moment of inertia I. Since the rod is massless, so there will not be any moment of inertia of the rod, but it is mass, okay, here, and the hinged point is this. That means we are considering the torque about the hinged point, so I would be M into L square, ML square, okay. So when you rearrange these equations, you can write it as ML square theta double dot plus 4K L square theta is equal to 0, and theta double dot, this would be cancel out, theta double dot plus 4K upon M, 4K upon M theta is equal to 0, and you can see this term is represented by omega n square. So omega n square is 4K by M, that means omega n is equal to under root of 4K by M. So you can see in the options, option D is the correct answer for this question, okay. So as you write down the correct equations, you will be able to find out the solution. But the important thing in the question is that we should not have to consider the mg torque. That is an important thing, okay. You can see in the vibrations chapter most of the questions are of this type, because generally they will give you the horizontal situations. So if you forget that mg torque is not considered in the horizontal conditions, you will get the wrong answer, okay. So you need to understand this. I hope you will understand the solution of this question. Thank you.